Module 4, Lesson 5, Multiplying with Area Models. I think the area models are so much fun, and they really do a great job of making multiplication concepts really just sensible, logical, showing what multiplication really looks like when we're working with larger numbers and multiple place values. So we're going to build on our understanding of arrays and number lines. So in some ways, an area model is almost like a combination of an array and a number line. Could be a helpful way to think about it. The scale is going to develop our number sense, and it's also going to help prepare us for geometry, algebra, and strengthen our mental math skills. It will also help us as we can expand out and work with larger numbers. It's also going to be an important foundation when we get to fractions, because you can get visual understanding of what fractions look like. So let's look at a few examples. Let's start with an expression like 13 times 6. And the key central idea of the area model is that we're going to be separating out our tens place from our ones place. So whereas in an array, we might just do 13 dots by 6 dots, what we're going to do is make it a line. So here's where our number line comes in handy, and this is going to be my 10, and this is going to be my 3. Now the other direction, I'm going to make this 6. So with 2 digits by 1 digit, we end up with 2 separate boxes. This box is 10 by 6, which is going to be 60. And this is 3 by 6, which is 18. And all we do is we add the areas together for our total of 78. This transfers a lot better to mental math than just doing the algorithm, right? So if you were to do this same problem with an algorithm 13 times 6, we're doing 6 times 3, which we know is 18, and then we carry the 1, 6 times 1, 1. So we're going to get the same answer, but if we try to do some of these simpler problems in our heads, and I can see this when kids are trying it, they start pointing at the air, and you can see them going this way, then this way, then this way, then that way, and there's just a lot of eye tracking, where we're going from right to left and left to right, and carrying and borrowing. There's not always a great place for it, so there are certain limitations. This it's easier. You can see, look how much bigger this box is than this box. We get all the sense of size. Now let's rewind just a second. So I mentioned that this combines the idea of array and number line. So just in case that's not immediately clear how, so if this were an array and we would have 10 objects arranged in rows, so on and so forth, we would go down 6 times. If we think about this as a number line, okay, so we're showing our lengths here and here. Okay, so hopefully that demonstrates what this would be like if it were an array. Another thing you can do when you're first introducing an area model is to maybe just start with 1 digit by 1 digit, okay, and actually take an array and then convert this to a length of 3 and a length of 6, okay, and then we can even draw boxes to show how, okay, we have the objects arranged in rows and columns, and that's the same thing as if we just have the outline of the box. Okay, and once we introduce that concept, then we can work with larger numbers. So just did 1 digit by 2 digits. If we wanted to do 2 digits by 2 digits, for example, 23 times 46. Now notice what I've done here is I've broken these into tens. Now I'm not going to make all of those as separate boxes, but especially at first, okay, to help us make sure our scale is solid and to reinforce the idea that this is 4 tens times 2 tens. Okay, and now we're going to end up with 4 boxes. Now the beauty of using these to calculate is that everything is based on times tables and place value, right? So for my largest box, 40 times 20, I just need to know how to do 4 times 2, which is going to be 8. And then I know that it's tens and tens, so I'm going to need 2 placeholders. 6 times 2 is 12. I have 1 0 as a placeholder. 4 times 3 is also 12. I'm going to have 1 0 as a placeholder. 6 times 3 is 18. Now, the other thing I like about this is that when I go back to add these up, I can start with my biggest, 800, and then adding 120 is easy because I'm not going to have anything in these places. I just add the 1 and the 8, so that's 920. That's going to take me to 1040, 1050, 1058. Okay, and if you can't do that in your head, that's fine. You could still maybe use stacking to do the last step. And then even when we stack, we can see it's mostly zeros and an 8, 5. So let's do a 3-digit number times a 2-digit number, and it's not going to be as much to scale when we get numbers this big, but we still can try to keep it somewhat to scale, right? So each of these is going to be 100. So altogether, this is 300. And as you can see, this is roughly 1/5. Probably it's a little bigger because we have to have room to actually write our numbers. So my largest box is going to be 300 times 20. So 3 times 2 is 6. And then I keep 3 placeholders. 3 times 4 is 12. 2 placeholders. 2 times 2 is 4 with 2 placeholders. 2 times 4 is 8. 1 placeholder. 4 times 2 is 8. 1 placeholder. 4 times 4 is 16. 6,000. 7,200. Then here you can choose what you combine. So I would take the 400 and then combine the two 80s. Now the reason I'm doing that is I want to try to make sure I'm not combining too much in the same place value. I'm trying to reduce my regrouping. So 7,200 plus 400 is 7,600. 7,700, 7,760, and then 7,776. And again, if you're not as comfortable doing the addition mentally, you can always go to an algorithm or use one of the other visual models we introduced earlier